Jai Hind. The topic which we are going to discuss today is functional testing. It is a part of Unit 4. So basically, what is functional testing? There is also another name of functional testing, that is black box testing, and it is also known as behavioral testing. So it is an approach to test whether program is considered as a black box. That is, you are giving some input to your code and your code is producing some output and you are inspecting that output. So what you are giving to your code, it is that input is termed as your test case, and whatever output is coming, you are checking its or you are verifying its validity. So here the program, it is considered as a black box. That is, you are not concerned what exactly been designed within the program. So the program test cases are based on the system specification or the functional requirements of the software. So how you will design the test case? You will design the test case on the basis of the system specification which has already been decided, or on the basis of the functional requirements which have been again written in the SRS of the software. It is based on the view that any program can be considered to be a function that maps from its input domain to its value in its output range. That is, you are giving input in certain domain and you are getting output in a specific range, and you are then verifying whether that output, the output which is coming, it is a valid one or not. Test planning can begin early in the software process. So in the black box testing, you are giving the input, it is known as test data, and we are having a system under the test and the output is coming on that test data. So ultimately, you are giving input, we are having certain set of requirements. Here we are having events, your input is interacting with this system, and finally it is producing some output. For an example, lock and key system. So if I talk about the functionality, what are the features of a lock, then what you need to know to use, it is made of metal, has a hole provision to lock, has a facility to insert. Then come on the feature of a key. It is made of a metal and created to fit into the particular lock's keyhole. So what are the action performed? Key inserted and turned clockwise to lock, and the key inserted and turned anti-clockwise to unlock. So we are having two states in this case. One is locked and another one is unlocked. And the inputs, key turned, we are turning the key and there are only two directions available, one is clockwise and another one is my anti-clockwise. And what is the expected outcome? So what here it is coming, it is actual outcome. Okay, but in your specification, you always have a expected outcome. So it is whether locked or unlocked. Why we go for the black box testing? Black box testing helps in the overall functional verification of the system under test. It helps in identifying any incomplete, inconsistent requirement as well as any issue involved when the system is tested as a complete entity. So this testing addresses the stated requirement as well as implied requirements. What are the techniques? We are having three techniques. One is boundary value testing, equivalence class testing, and the decision table testing. We will cover them one by one. So what is boundary value testing? How to use the knowledge of the functional nature of a program to identify test case for a program. Boundary value testing has focused on the input domain but helped to develop the range based test cases. For instance, if I am saying that I am giving a number from 0 to 10, then what is the boundaries? 0 and 10. So my test case, it could be any range up to 0, here any range greater than 11, sorry, any range minus 1, and here any number between 0 to 10. So I could have 3 test cases in this case if I talk about the boundary value testing. So boundary value testing, it is basically focused on the input domain but help to develop the range base. We are working on a range. If any one point satisfy my outcome, valid outcome is coming, then it mean that all the elements which are present in this range, they will satisfy the requirement. Test values, sizes or quantities near the design limits. Generally, we design near the ranges. Error tend to occur near the extreme values of the inputs. So, the robustness, how does the software react when the boundaries are exceeded, and your boundary value testing technique is based on this concept. Here we make a single fault assumption which says that the failures are rarely the result of the simultaneous occurrence of 2 or more faults. Generally, your boundary value analysis, it depends on this assumption. The basic idea of boundary value analysis is to use the input variable values at their, we have just seen the example, at their minimum, just above the minimum, at a nominal value, just below the maximum, and at the maximum. So, where in the previous example we say that the I could be any value 0 to 10. So, minimum it says 0 and your maximum it says 10. Nominal it could be any value, let us suppose it is 6. Just above the minimum, so let us suppose it can be my -2, and just below the maximum it says it could be my 9. So, if you look here the boundary value I am having A, B, C and D, and here my test cases are being generated. So, it is going to be 1. Just above the minimum, it is going to be my 1 value. Here we will understand the boundary value analysis with the help of a triangle program. The triangle program accepts 3 integers, let us suppose A, B and C. These are taken to be the sides of the triangle. The integers A, B and C must satisfy the following condition. Here we have given the conditions. We are having 6 conditions. C1 says that the x should be between 1 to 100. Similarly, C2 says y should lie between 1 to 100. Similarly, we are having the condition for z. Another C4, C5, C6 that thus x is always less than the summation of y plus z. Similarly, length of y is always less than the summation of x and z length, and similarly the thing goes with C6. So, here the boundary values test cases, these are the test cases being generated. Here we have taken x, suppose x is 50, y is 50 and z is 1, then it is coming to be my isosceles triangle. Then in the second test case, if I take 50, 50 and 2, then again it is isosceles. So, these are the test cases which we have designed, and these are my outcomes. And also if you look, we have taken the case where we are not having a triangle. Another important case can be a previous date is a function of 3 variables, month, date and year. It returns the date of the day before the input date. The month, date and year variables have integer values subject to these conditions. C1 says the month value should always lies between 1 and 12. Similarly, we are having the range for the day value and for the year value. So, here the previous boundary value analysis test cases. So, what we are having 1 and 12, 1 and 31, 1900 and 2025. So, we have taken month is 6, day is 15 and year is 1900, that is nominal value. We for these two we have taken the nominal, and for these we have taken at the minimum value. So, similarly then nominal, and here we goes with above the minimum value. So we have taken 1901, then again 1962. If you look at here, what we had, it is 2025, so here it is my nominal value, and here what we have taken, maximum and below maximum. So these are the cases. We have make a variation here corresponding to year. Similarly, what we have done, we have now we have fixed this value. We are playing around with this value, and then we are playing around with the month value. So this is how we generate the test cases. And another important, that is my invalid date. This case is also very important to check. Boundary value analysis works well when the program to be tested is a function of several independent variables that represent bounded physical quantities. If you are not aware of their boundaries, of their ranges, then you cannot go with this analysis. A quick look at the boundary value analysis test cases for previous date shows them to be inadequate. For example, very little stress occurs on February and on leap year. So we can say that such kind of examples, if we are having such kind of cases in our software, then we cannot go with the boundary value analysis. The real problem here is that interesting dependencies exist among the month, day and year variable. Boundary value analysis test cases are rudimentary because they are obtained with very little insight and imagination, because we are always working. We just need to know what are the boundaries, what are the ranges, and accordingly we are generating the test cases. Ad hoc testing, this testing is carried out using no recognized test case design technique. It occurs when the tester uses domain knowledge, experience and information about soft spots to derive the test cases. Generally, they are the expert persons, mostly intuitive and least uniform way of doing such kind of testing, totally dependent on the ability of the tester. Also known as spatial value testing, out of box testing or gorilla testing. Now the next is equivalence class testing. In equivalence class testing, the use of equivalence classes as the basis for functional testing has two motivations. We would like to have a sense of complete testing, and we would hope to avoid the redundancy. As we have seen in this case, a lot of redundancy is, in this case, a lot of redundancy, that is, we are having isosceles multiple of times, then not a triangle, not isosceles, scalene, equilateral. So we need to avoid such kind of redundancies. Why to go for a huge amount of test cases? If we expect the same result from two test cases, we consider them equivalent. So a group of test cases forms an equivalent class if they all test the same thing. That is, in the previous example, if all my test cases they are saying equilateral triangle, then it implies that they are equivalence cases. If one test catches a bug, the others probably will too. If one test does not catch a bug, then in case the same thing does not come up with the other equivalent value. Important aspect of equivalent classes is that they form a partition of a set, where partition refers to a collection of mutually disjoint subsets when the union is the entire set. That is, if I am having a subset T1, T2 and another T3, T4, then the union of this will give me entire test set. This suggests two things. Entire set is represented provides a form of completeness, and disjointedness ensures a form of non-redundancy. That is how we are achieving the non-redundancy, with the help of disjoint concept, and the completeness is provided because if I join the two different subsets, I will come up with the entire set. The idea is to identify test cases by using one element from each equivalence class. So, in equivalence testing, what we are doing, we are having a valid input, we are giving it to the system, and we are getting some output. Most of the time, equivalence class testing defines classes of the input domain. However, equivalence classes should also be defined for output domain. Hence, we should design equivalence classes based on both input as well as output. So, what the equivalence class testing says? It says that you will partition your sets, and from each set, what you are doing, you are selecting a sample, and it is acting as a test case. If my output is valid for this sample, then automatically for any sample present in this class, it would be a valid answer. Same problem which we have studied earlier, that is my triangle problem. So, in this case, output, because here in the equivalence class I need to have a range for my equivalence classes for my output. So, I am having 4 classes: equilateral triangle, isosceles triangle, scalene triangle, and not a triangle. So, I am having 4 outputs. So, here I am having these test cases. For example, for ABC value, I am having the equilateral, then for isosceles, scalene, and for a not a triangle value, and this is how I have decided the things. Equivalence class testing is clearly sensitive to the equivalence relation used to define the classes. If we base equivalence classes on the input domain, we obtain a richer set of test cases. So, here what we have done, we have designed the test cases based on my expected output, but if I design the test cases based on the input, then I will get the more number of test cases. Equivalence class testing is appropriate when input data is defined in terms of intervals and sets of discrete values. Equivalence class testing is strengthened by a hybrid approach with boundary value testing. That is, you can combine the two approaches. Strong equivalence class testing makes a presumption that the variables are independent, and the corresponding multiplication of test cases raises issue of redundancy. If any dependencies occurs, they will often generate error test cases. Next is decision table based testing, which we will cover in next lecture. So, we have discussed 2 techniques. One is my equivalence class testing, and another one is the your boundary value analysis. These are the papers which you can refer if you want to learn more on testing. Thank you and Jai.